All right, this is part 5 of our lesson on solving and graphing quadratic inequalities. All right, the first thing we need to do is find the zeros of this function, the x-intercepts of the parabola. So this is factorable, so I'm definitely going to just go ahead and factor. Okay, so 9x squared minus 25, this is the difference of two squares. So you can just immediately go 3x plus 5 times 3x minus 5. Okay, so that makes it easy. Now, we need to keep going though and set these factors equal to 0. So 3x plus 5 equals 0. 3x minus 5 equals 0. Okay, subtracting 5 from both sides gives me 3x equals negative 5. Okay, dividing by 3 gives me x equals negative 5 over 3. So that's one of my zeros, okay, one of my x-intercepts. Meanwhile, over here I'm going to add 5 to both sides. So that'll give me 3x equals 5. Then I'm going to divide both sides by 3. And that's going to give me x equals positive 5 over 3. So these are my two x-intercepts of this parabola. So when I graph these on the number line in a second, am I going to use open circles or closed circles? I'm going to use closed circles because it's less than or equal to 0. These values represent where the function is equal to 0. So because we want the equal to 0 part, we're going to include the endpoints. All right? If it had just been less than, I would use open circles. So let's put some closed circles. So we have negative 5 over 3 and positive 5 over 3. Now I'm just going to do a rough sketch here. So I'm going to keep it really simple. I always include 0 on my number line. But okay, I mean I've got negative 5 over 3 and positive 5 over 3. So I'm just going to put those sort of like this. Okay, you know what? I feel like spreading it out a little bit more. Okay, that's all we need. Now, like we said, we're going to do closed circles. Okay, now for my visual learners, I'm going to show you how we can finish this problem in like under a minute. Okay, because this is a parabola. It is an upward facing parabola because it is positive. Okay, so in your mind, you should be picturing this. And if you were going to solve it graphically, you would have to show this. But we're talking about a parabola, an upward-facing parabola that has these x-intercepts. Okay, so a parabola such as this, that has an x-intercept here and an x-intercept there. Now, this equation, this inequality is asking where is the function less than or equal to 0? All right, well the function is going to be less than 0 where it is below the x-axis. Okay, and it's below the x-axis in this area. All right, this is where it's below the x-axis. So in terms of x values though, that's the part of the graph that goes between the two zeros, between the x-intercepts, is where it's below. So immediately you will know that this is the part that you will fill in. Okay, now I'm going to go back and do it using test values, but that's how you would do it visually. So anyway, back to test values. But we already know it's going to be in here, so just watch out for that. Now, as far as test values go, please understand that we have now divided this number line into three sections. We have this yellow part, we have this blue part, okay, going between the two zeros, and we have this pink part, or red or pink, whatever you want to call it. All right, these are the three zones. So, I like to make a little chart out of it, like this. Okay, and I'm going to need a test value from each one of these zones. So I'm going to need something less than 5 over 3. Now, it will be helpful to know what the decimal value of this is. So you could put negative 5 over 3 in your calculator and give me a decimal. Okay, 5 over 3. If you hit the toggle key, maybe I should show you. I'm talking about this button right here. If you hit your toggle key, it will give you the decimal version. So 5 over 3 is approximately 1.7. Okay, so just keep in mind that this is approximately 1.7 and this is approximately negative 1.7. So when I pick my test value, I need to pick a value that is less than negative 1.7. Okay, so for example, x equals negative 2 would work because that would be to the left of negative 1.7. In the blue zone, I'm definitely going to pick 0. I always pick 0 when it's in the zone because 0 is so fun to work with. And over here, I'm going to pick x equals 2. All right, for the same reason as the negative 2. It's the first integer to the right of 1.7. Okay, now I'm going to take these test values one by one and I'm going to plug them back into the original inequality. However, I'm going to use the factored form because I find that easier to work with. Alright, so keep that in your mind. 3x plus 5, 3x minus 5. Okay, so I just copied down the inequality. 3x plus 5 times 3x minus 5 is less than or equal to 0. And I'm going to copy that down in all three zones. Okay, now heading back to the first one though. So now I'm going to take my x value of negative 2 and I'm going to substitute it in for these x's and see what I get. So for now I'm just going to set this up though. Alright, what am I doing, you might ask. So x equals negative 2. So this is 3x, so that's 3 times negative 2. And 3 times negative 2. Okay, so if I evaluate this mess, look, 3 times negative 2 is negative 6. So I've got negative 6 plus 5. And again, that's negative 6 minus 5. Negative 6 plus 5 is negative 1. Negative 6 minus 5 is negative 11. A negative times negative is a positive, so this will be positive 11 less than or equal to 0. And then you ask yourself, is this true? Is 11 less than or equal to 0? I don't think so. I think not. Okay, 11 is not less than or equal to 0. So we will say no, really loud. That means x equals negative 2 is not a solution to the inequality. That means that none of the values in the yellow zone will be solutions. And we will show that by leaving this zone empty. Okay, we just won't draw anything in as for the solution. Okay, now let's do our test value of 0. Okay, so I'm doing 3 times 0. Okay, well 3 times 0 is 0. So I've got 0 plus 5 and 0 minus 5. Well, 0 plus 5 is just 5. And 0 minus 5 is negative 5. Positive times negative is a negative, so I've got negative 25 is less than or equal to 0. So we ask ourselves, is this true? Is negative 25 less than or equal to 0? Yes, yes it is. All negative numbers are less than 0. So that means 0 is a solution to the inequality. That means that all of the values between negative 5 over 3 and 5 over 3 are solutions as well. We will show that all of these values are solutions by drawing this segment in between them. All right, that segment represents all the solutions. Okay. All right, look familiar? Isn't this just like what we came up with from the graphical method at the beginning? And last but not least, let's evaluate for x equals 2. Okay, so that's 3 times 2, 3 times 2. All right, so that'll be 6 plus 5 and 6 minus 5. 6 plus 5 is 11. 6 minus 5 is 1. So that gives me 11 is less than or equal to 0. And then you have to ask yourself, is this true? Is 11 less than or equal to 0? Clearly, no, that is not true. 11 is no way less than 0. That means 2 is not a solution to the inequality. That means none of the values in this red zone will be solutions to the inequality. So we'll just leave that blank. So that just leaves the portion in between the two endpoints here. So that is the graph right there, okay? Which we knew it would be based on our graphical approach at the beginning of the problem. Now let's go ahead and write the solution. Okay, in interval notation, the solution would just be like this, from negative 5 over 3 to positive 5 over 3. So, okay, negative 5 over 3 to positive 5 over 3. We will use square brackets, all right, to show that the endpoints are included in the solution set. So that's it. That's how you would write the solution in interval notation. Okay, I could put a box around it. That's how done it is. Okay, but you should also be prepared to write your answer as an inequality, especially because of multiple choice tests. You might not see this as one of the answers. You might see the following. If I want to show all the values between two numbers, as an inequality, it looks like this. Why did I put 1? That has nothing to do with it. Maybe that's supposed to be a negative sign. Negative 5 over 3 is less than or equal to x, which is less than or equal to positive 5 over 3. This means exactly the same thing as my interval. It means all the values between negative 5 over 3 and positive 5 over 3. And the equal to part means including the endpoints. So that's it. That's how you would write the solution as an inequality. Okay. All right, that was part 5. And I am going to have to stop this video here. Okay, that's problem number 5 we just finished. There's only one problem left. I'm going to try to make that one last video. But this is a marathon, and I'm not getting any younger. See you on the next video.